So as far as your quizzes go, there was 2 points of extra credit built into it. So I take it out of 10. I'll take all your quizzes out of 10. But this was actually all possible in it. Opportunity to have a couple extra credit points in there. Any questions over anything at all before we get going? Continue on with pardon me, with this graph straight function. Things go okay? All right, well, let's finish up doing the sines and cosines and shifting them around types of graphs, and then we'll get into the other 4 trig functions. Pardon me, goodness gracious. All right, so we talked about vertical shifts last time, right at the end before we took the quiz. It said that we have this number on the outside, we're going to shift up and down that far. So we mentioned on this one, since it's negative, it'll go down, and it'll go down by a 1/2 unit. So let's just skip over that part for the time being and see if we can put all of these things together. So if we look at the next example, we got all 4 things that we talked about going on in this one. We have an amplitude change, we have a period change, we've got a phase shift, and we've got a vertical shift. So how do we do, or what do we look at, I should say, for the amplitude? What do we look for the amplitude change? What tells you about the amplitude change? Yes. Okay, good. The coefficient is right in front of the trig function, that 2, right? So what is the amplitude going to be in here in this case? 2, right? We do the absolute value of that number. If it happens to be negative, what would a negative tell you? If there was a negative sign here instead of a positive sign, what would it tell you? Yeah, flips it upside down, right? It takes it upside down, flips it across the x-axis. All right, so that 2 in front tells you about the amplitude. What tells you about the period change? Yeah, the coefficient on the x, right? So how do we find the period change? What do we do? Good. We do the 2 pi and divide by that coefficient, right? It's not simply that coefficient. We take what the period started at, which is 2 pi, and divide by the pi over 2, which in this case gives us 4. How about for the phase shift? What do we do to find the phase shift? Yeah, set the inside piece equal to 0. Good. So it's at the pi over 2 times x minus pi over 3 equal to 0. We'd multiply both sides by 2 over pi to get rid of the pi over 2. And we would get 2/3 when we do that. The pi's would cancel. Since that number is positive, which way is your graph going to shift? To the right, right? All right. And then what number, finally, what number tells you about your vertical shift? Yes. The 3 does, yep. And so this, in this case, is going to go which way? Up. Good. All right. So now let's put all these pieces together. We'll start with the original sine graph. Again, if I like to think of the y-axis as kind of a starting line. If I think of the y-axis as a starting line, where's your original sine graph start at? At 0, right? Yeah. Down here, goes up to 1 at pi over 2, is 0 at pi, -1 at 3 pi over 2, 2 pi, and repeats. up and down and up and down and up, so on. We can handle the amplitude and the period just by changing the scale, right? We don't have to redraw the function. We can just change the scale. Since the amplitude of the new graph is supposed to be 2, instead of going between -1 and 1, what should we go between? -2 and 2, right? So we can just multiply all your y's by -2 and change your scale. So that amplitude change does. It's just a scale change. So instead of going 1, 2, 3, 4, we'll go 2, 4, 6, 8. Who do we appreciate? No? Too corny of a joke this morning? Fine. Don't give me a giggle. That's perfectly fine. All right. The period is now 4, so what can we relabel the 2 pi here with? 4, because we're changing the 2 pi period to a period of 4. So I can change this to a 4. If that becomes a 4, the pi becomes 2, and the ones in between will become 1 and 3. So we end up with what basically looks like a standard scale, doesn't it, in this case? So far, so good. Makes it a lot easier than having to redraw the graph twice. Just change the scale. Now, based on this new scale, we'll do our shifts. The 2/3 here tells us to go right 2/3, right? So if I go right 2/3, this point, let me change color so I can see it a little bit better. Or don't change color. No, God forbid you open the menu. 2/3, 2/3. Everything shifts over 2/3 of a unit. We get that one. So again, we're moving over 2/3 of the unit. So the one that was at 0 goes to 2/3. The one that was at 1 goes to 1 and 2/3. 2 goes to 2 and 2/3. 3 goes to 3 and 2/3, and so on. Just shifting it to the right. And then finally, the last thing we need to do is go up 3, right? And again, based on the red graph now. So this number here that's at 0 would go up to 3. This number here that's at 2 would go up to 5. Back to 2. Back to 1. Back to 2. This one 2. 1. Or 3, I should say, not 2. 3. 5. 3. 1. And so on. And so that blue one that I'm drawing here would be your final graph. Again, on your exam on Friday, I will ask you amplitude, period, phase shift, vertical shift first. Okay? So I have to be listed parts, so let it fill those out. And then ask you to graph it. So when you see a problem, there'll be 5 parts to it. First 4 will be labeling amplitude, period, phase shift, vertical shift, and the last part will be getting the graph down. Any questions about how we got those individual things? That part okay? work on that last one for a minute or two, and then we'll chat about it. While you're working, I'll hand out the new handout. Are we ready to chat? Or you want another minute? Here. Right. All right. Let's go ahead and chat. How did you find the amplitude? What did you do? Yeah. 1/3? Yep, that's that coefficient that's out in front of the cosine, right? Okay. How about the period? What do we do? Say it again. Yeah, divide the 2 pi by 1/4, and we get 8 pi. Good. We divide by that coefficient on the x there. What do we do for the phase shift? Good. Yep, set what's inside the parentheses equal to 0. So we'll subtract the 3 pi over 2. And then multiply by 4. So we'll get, what, negative 6 pi. And in this case, since it's negative, that tells you what? Goes left, right? Goes to the left 6 pi. And then finally, vertical shift. Down 1. Good. So far, so good? Again, like I said, this will be parts 1 through 4 of problem on the test. All right. Let's start with our cosine graph. Again, starting off of the y-axis, where does cosine start? Cosine start at 1. Goes down to 0 at pi over 2. Negative 1 at pi. 0 at 3 pi over 2. Back up to 1 at 2 pi and continues. And then does the same thing on the other side. For the amplitude, instead of doing 1, 2, 3, 4, what should the numbers go? We'll go up by 1/3. Good. It should be 1/3, 2/3, 3/3, 4/3, right? We're dividing all of them by 3, multiplying all by 1/3. So we'll have 1/3, 2/3, 3/3, which is 1, 4/3. And then the same thing down here. That 1/3, we're just multiplying everything by 1/3 on the y-axis. Instead of 2 pi for the period is now 8 pi, which means halfway is 4 pi, which means this number should be 2 pi, and this one should be 6, and then this would also be 10 over here. And then the negatives would be over here. Are we okay with the amplitude change and the period change? Now we shift. We need to go over to the left and down, right? I'll do it in 2 steps, but those are the 2 things we need to do, right? Go left 6 pi. So this point here, 1, 2, here to that point right there, right? To 6 pi. This point will go 1, 2, 3 over to this part. This part will go here. That'll go here, up, down, down, up, down, down. Tracking points as we go. before I move it up, notice that we moved everything left 6 pi, but it also kind of also looks like we moved everything to the right 2 pi, doesn't it? It's not a huge surprise, because if I take 6 pi and add it to 2 pi, we get 8 pi, which is the period, right? I think it repeats every 8 pi anyway. So moving left 6 pi or adding 2 pi, it should look identical because of the way the graph is behaving. And then finally, everything goes down 1. We want to go down 1. This point here goes all the way down to -1. This point goes to -2/3, -1, -4/3, -1, -2/3, and likewise on the other side. And again, I'm not looking for perfection in these. I'm looking for that you have conveyed to me that you understand what's going on. Certainly mine are not perfect by any stretch of the imagination. But you should have the shift correct. You should have the scale changes correct. But again, it doesn't look perfect. Like here, I missed my point. I don't really care about that. I just want to know that you understand the general idea of what's going on. You want something that's perfect, you're going to put it in a graphing device anyway and let it graph. The idea behind this is that if you put this in a graphing device, it should look something like what you came up with. That you have an idea that you typed it in correctly and not typed it incorrectly. You typed it in correctly. Is okay? Well, let's go on then to the new stuff. We've graphed 2 of the trig functions. How many more do we have to go? How many trig functions do we have total? 6? Yeah, so we have 4 more graphs to do. Good. So let's do tangent. When we did sine and cosine, we plotted points and then they played connected dots. Let's be a little bit more analytical about this than what we were doing before. And what I mean by that is, rather than just doing some plug and chug types of things, plot in some points, pick some x's, get out some y's, play connect dots, let's actually use the properties that we already know about these functions to help us get characteristics that must happen on the graph and then get a sketch, okay? So, in particular, if we have y equals tangent of x, how can I rewrite that in terms of sines and cosines? Good, yeah, be sine of x over cosine of x, right? So now we've got a fraction. So let's see if we can analyze this by the properties of sines and cosines that we already know what happens with those graphs. In particular, let's look at whether this function must be equal to 0. Well, if you're looking for when a fraction is equal to 0, what must be true about the fraction? 0 on the top, right? So the tangent will be 0 when the sine is 0. But when is sine equal to 0? What values of x give you sine is equal to 0? Where does the sine graph cross the x-axis? 0 and pi and 2 pi and negative pi and negative 2 pi, right? All the multiples of pi. So where the sine crosses the x-axis, the tangent must also cross the x-axis. Because where the sine is 0, the tangent is 0. And so all I did here was just label x-intercepts to start with. And again, that's because where the sine is equal to 0, the tangent must also be equal to 0. All right, so let's go back now how the tangent function is defined. It's defined as a fraction. Where do we know we have problems with fractions? What can't you divide by? is when the denominator is 0, right? So we'll have issues when the denominator is 0 or when cosine is equal to 0. So what values of x are bad numbers to plug in? When is the cosine equal to 0? Pi over 2, 3 pi over 2, 5 pi over 2, right? And all those odd multiples of pi over 2, negative pi over 2, negative 3 pi over 2. From your knowledge of graphs of functions from college algebra, when you get a 0 on the denominator, what kind of a thing typically pops up in your graph? Like, for example, if you wanted to graph y equals 1 over x, what kind of a thing do you get at 0? There's a hole, but what kind of hole happens there? Is it a hole that looks like this? Yeah, we have one of those vertical asymptotes, right? That's what the graph of 1 over x looks like. So at all of the odd multiples of pi over 2, we're going to get vertical asymptotes here. And again here, what I'm looking for is a rough sketch of the graph. We can put in a couple of particular values in, but right now I'm just interested in what a rough sketch of the graph will look like. I probably shouldn't make my scale so big on my y's. It's okay. All right, in particular, let's just, like I said, I want to try to get this a little bit more analytically. When we've got these vertical asymptotes, we know that the graph should get really, really close to that line, but never touch it, right? Okay. There's kind of 4 ways that you can do that in this case, right? I could go down and back up. I could go up and back down. Or I could crisscross, right? Like that. There's basically 4 ways I can do that in one of these regions, right? Right? I could be a U shape up, a U shape down, up and to the right, or down and to the right. We just need to figure out which one it is for us. Let's do it analytically again. Here we're going to be putting in numbers between 0 and pi over 2. If I'm putting numbers in and thinking about them as angles, what quadrant are we talking about between 0 and pi over 2? Quadrant 1, right? So tangent should be positive, which means I better go that way, right? Over here, what quadrant are we talking about between negative pi over 2 and 0? 4, right? Because you'd be rotating downward. Right? Okay. In quadrant 4, is tangent positive or negative? Negative. So we have to be going that way, right? So just from that analysis, we should have a graph that goes like that. We do get another point that should be on the graph, a couple of points. When you put in pi over 4 for tangent, what do you get out? You put pi over 4 into the tangent, what do you get? Sine of pi over 4 and cosine of pi over 4 are the same, so you get 1, right? So this should go through the point pi over 4, 1, and negative pi over 4, negative 1. Like I said, I should make that scale a little bit smaller. That graph should go through, or I just put that dot. Okay. Not too worried about accuracy. I'm more worried about shape. It goes up and to the right between those two things. How about the next piece? From pi over 2 to pi, what quadrant are you talking about? 2. Tangent positive or negative in quadrant 2? Negative. So we should be down here again, right? Pi to 3 pi over 2, what quadrant are you talking about? 3 and tangent is positive. So we should be up here, right? So we get another copy of this graph over here. And it continues over and over again like that. So here's what your tangent graph looks like. Things we notice. We don't worry, by the way, with these 4 functions that we're going to do today, we don't worry about amplitude because Remember, amplitude was half of low point to high point. Is there a lowest point, highest point for tangent here? No, so we don't worry about amplitude for this. But things we will worry about, x-intercepts. These are the multiples of pi again, just like they were for sine. Vertical asymptotes. These are your odd multiples of pi over 2, or pi over 2 plus n pi. Remember, these are the x-coordinates of where the cosine graph crosses the x-axis. Asymptotes are lines. And since they're vertical lines, they have equations x equals some number. That's why I have the x equals in there. That was weird. Last thing here, period. Now, sine and cosine repeated every 2 pi. What do you know about this graph? What is it? How long does it take to repeat? How long is this interval here? Pi. And it looks exactly the same here, right? Repeats here in pi, repeats here pi. Same way along the line, or we're on there. So your period for tangent is pi rather than 2 pi. All right. Again, just more interested in basic shape here. What does the tangent graph look like? Okay. Important characteristics of the tangent graph will be where does it cross the x-axis, where are the vertical asymptotes, and then it's going up and to the right. Pardon me. Okay. Well, let's flip to cotangent then. Let's see if we can do the same type of analysis that we just did for tangent. It's much better if we can do things from an analytical point of view. What I mean by that is building on things that you already know to get new things than it is to just try to plug and chug and guess and check and those kinds of things, right? Build on what you already know to try to get the new stuff. Okay? What did we do with tangent? The first thing we did was rewrite it in terms of sines and cosines. How can we rewrite cotangent in terms of sines and cosines? Yeah, cosine of x over sine of x. Good. What did we do before tangent? We figured out where it crossed the x-axis and where it had asymptotes, right? What told us about where the tangent crossed the x-axis? The numerator or the denominator? Numerator, right? So cotangent will cross the x-axis when the numerator is 0. Where does that happen? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all of those places, and the negatives, right? All those odd multiples of pi over 2. The other thing we looked at was asymptotes. Where do vertical asymptotes typically appear? When the denominator is 0, right? In this case, we're looking for when sine is 0, and you told me before sine is 0 where? At 0, where else? Pi, where else? 2 pi. Negative pi. Negative 2 pi. Right? So far, so good? Same game we played before, right? Yeah. Okay. So look very thrilled about doing graphs. All right, let's do this same again, one more time. Let's do the analysis that we talked about with tangent. I broke it up into intervals, right? So let's go 0 to pi over 2. Cotangent should be positive, right? So should we go this way or this way? Up or down? If it's going to be positive. Down, right? Because I have to have positive outputs, right? It should be this way. Right? The values coming out of cotangent should be positive, so they should be above the x-axis, right? So it goes this way. From pi over 2 to pi, we're in quadrant 2. Cotangent is negative, so we should keep going down, right? So we get that little S-shaped curve that looked like tangent. It's just upside down. And then you can apply the same analysis on the next batch. Cotangent is positive in quadrant 3 and negative in quadrant 4, so it looks like that. And then, of course, we have that repeating pieces again. Again, if you want to be a little bit more accurate, you can plot some points, right? When we plug in pi over 4, we should be at 1, which means my graph wasn't horribly accurate, right? But like I said, I'm not as worried about accuracy as I am in basic shape, right? Basic shapes of graphs can tell you a lot about what's going on here. All right, so let's write some basic properties here. Your x-intercepts now are the odd multiples of pi over 2. Your vertical asymptotes are the multiples of pi. Because again, those correspond to the x-intercepts for cosine and the x-intercepts for sine. And then finally, again here for period, how long is it going to take for cotangent to repeat? Pi again. Yep. Questions on how we got this graph? Or either of the two graphs? So far, so good? Again, notice that I'm breaking everything down, going back to sines and cosines, right? Not trying to reinvent anything. All right, so let's do the same thing for the other two functions. We've got 2 more to go. To help us get a graph of secant and a graph of cosecant, we're going to put in a helping graph. But again, for the helping graph that we use, let's do the exact same thing for secant that we just did for tangent and cotangent. Let's rewrite it first. How can we rewrite secant? 1 over cosine, good. So as a helping graph, let's put in the cosine graph. And I'm going to put it in a different color here so that I emphasize here that it's a helper. So I'm just drawing in the graph of cosine. Remember, your cosine crosses the y-axis at 1 and then has x-intercepts every odd multiple of pi. Yeah? Is this okay? All right. This graph that we just drew is not part of the secant graph. I'm using this to help. Okay? Let's first notice, does the secant graph ever cross the x-axis? Is secant ever equal to 0? Again, you told me before, a fraction is equal to 0 when what happens? When the top is 0, when the numerator is 0. Is the numerator ever 0? No. Okay. So it never can cross the x-axis. There are no x-intercepts. Okay. Well, what about asymptotes? Can this thing have asymptotes? Yeah, it's going to have asymptotes when cosine is 0, right? Notice when those are already on the graph, aren't they? Good. I've already put them on there. So I'm going to go back here and try to change my color. We know there's going to be a vertical asymptote right here. We know there's going to be one right here, one right here, here, and so on, right? We're going to get a vertical asymptote every time that cosine is equal to 0. Now let's see if we can get the rest of this graph. When the cosine gets smaller, we're putting smaller and smaller numbers in the denominator. When you divide by something very, very small, what happens with your fraction? It gets very, very big, right? Think about it. If you divide by a half, that really multiplies by 2. If you divide by a tenth, that's really multiplying by 10, right? If you divide by a billionth, it really multiplies by a billion, right? The smaller the number in the denominator gets, the bigger the fraction gets. So this must be going up this way, and must also go up this way. So notice we get that U shape upward right there. Because as the cosine goes down, the secant's going to go up, right? So as this gets smaller, the secant gets bigger. And notice these are not positive values, so the reciprocals must also be positive. There's nothing to flip the sign, right? What's going to happen in the next part? Are we going to get another U shape up at the top? No, it's going to be down at the bottom, down here, right? We're going to get one that goes this way. And then it will start repeating. It'll go up over here, down over here, up over here. So let's label some important parts of the graphs here. So vertical asymptotes are going to be all those odd multiples of pi over 2. We already said there are no x-intercepts, right? There's no place where the graph crosses the x-axis. We do get a y-intercept here. But let's look at the range. Because the range is a little bit different, right? We don't have an amplitude. Because remember, we're not going to talk about amplitude. Now, there's no highest and lowest points. But notice in this case, there's a hole in the range, right? Our range goes from negative infinity up to -1, and then it jumps to 1 to infinity. It does include -1, so I have a closed bracket on the -1, and it does include 1, so I have a closed bracket on there, right? But there's a hole in the middle for the range. Finally, what's the period here? So how long does it take to repeat in this case? It's 2 pi in this case, right? Because notice here's 1 pi interval. It didn't repeat in the next pi interval, right? So it's going to be 2 pi in this case. If it were pi, it would have to be up here. This okay? All right, we got 4 minutes. I think we can get the last one. And we'll do more of this on Wednesday as well. But I think we can get this last one down. Cosecant is equal to what? 1 over sine. So let's put in the sine helper. Oh, I should have picked another color. Too late now. Already drawing. Couldn't possibly erase it. It's only on the computer and all. There's the sine helper. This is not part of the graph. This is just a helper, right? By the way, asymptotes are also not part of the graph of the function. Asymptotes are just helpers, right? They're just helping you guide where you're drawing the graph. Looking at the graph of the sine, where do you think we're going to have asymptotes? Yeah, pi. Good. At pi, at 2 pi, at 0, at pi, negative 2 pi. All the multiples of pi again, right? Because that's where the sine graph crosses the x-axis. We agree? And then just like what we did for secant, we're going to have the U shape going up, right? Because as the sine gets smaller, cosecant gets bigger. We'll have a part down here in the negative, part up here in the positive, down here in the negative, positive. Again, the sine graph is just in there for a helper. The actual graph are your little U-shaped pieces there, right? So just to finish it off, let's write the important parts again. Our vertical asymptotes are the multiples of pi. The range here again looks like the range for the secant. It has that hole in the middle again, right? Between -1 and 1. And then finally, what's your period? 2 pi again. Good. So just to summarize, sine, cosine, secant, cosecant have a period of 2 pi. Tangent and cotangent's periods are pi. Okay. We'll play around with this a little bit more next time. I'll get a review posted for your exam posted this afternoon on Moodle, so you can start looking at that if you'd like. Yeah, everything up until now will be on there. Yep. Yep. We'll talk more about it on Wednesday as well. All right. Have a good one. See you Wednesday, if not before.